Welcome to the Device Manager portal tutorial. In this video, we will walk you through the key features and functionalities of the portal that allows us to efficiently manage MR40 routers. Let's begin by signing in to the portal. This is the main landing page of the Device Manager portal. Upon logging in, users are greeted with an overview of all managed devices. At the top, there's a search bar where you can search for a specific device using parameters like serial number, MAC addresses, label, or other identifiers. This feature allows for quick and efficient navigation, especially when managing a large number of devices. Let's start by entering the device serial number. When I entered the serial number, a small row appeared displaying an overview of the device details. This includes the device label, the assigned port group, status, which shows as reachable. Additionally, we can see the use data value, the reseller information, and the last update timestamp. On the right side, there are two action icons. The red cross symbol, when hovered over, displays deactivate this device, indicating that the device is currently activated. When we click on it, we have to click on submit in order to deactivate the device. Next to it, the blue info icon provides access to the device details page, where more in-depth information and management options are available. The summary allows for quick insights into the device status and connectivity at a glance. Let's begin by looking at the device info page. At the top, you'll notice the label field. This is used to identify the name or assignee of the device. Labels make it easy to track multiple devices efficiently. We can add this label by clicking on this Update Label icon. Next, we have the serial number starting with MR40 and the device category, which indicate whether the device is Cat6, Cat12, or Cat20. This helps us understand the capabilities of the device at a glance. The port group section displays the network preferences and band locking options. For instance, this device is currently set to AT&T. We can lock it to specific bands such as AT&T Band 14 if the signal strength is strong. Similarly, this applies to T-Mobile and Verizon, allowing adjustments based on signal availability and requirements. We can make changes to the port group by clicking on Change Port Group icon and selecting the desired port group. Below the port group, there's Use Data field, which shows the data used in MBs in a month pass. Below that is the device status field. This indicates whether the device is reachable or unreachable. If the device becomes unreachable, this label will turn red, making it easy to identify devices requiring immediate attention. Next, we have the device plan section, which indicates the active data plan for this device. This could be an unlimited plan, or it might show specific data limits like 100 GB, 350 GB, or 500 GB. You can also update the plan directly from here if needed. The pass status and SIM status fields indicate whether the pass is activated and whether the SIM is registered with the network, respectively. These are crucial for ensuring seamless connectivity. Moving on, we have a field of SIM provider which states the current network like AT&T, Verizon, etc. Further down, you'll find details about the primary and secondary LTE bands along with their signal strength. This information helps us diagnose and optimize the device connectivity by showing detailed signal metrics. On the right, we have the tower connection info, which provides additional metrics such as reference signal received power, reference signal received quality, and signal to interference plus noise ratio values. These metrics indicate the quality of the connection to the nearest tower and can help us troubleshoot weak signals. The antenna signal strength sections provides a visual representation of signal quality on 4G, 5G antennas, making it easier to assess if any adjustments are necessary. Here we can see the M1 module's last activity timestamp, which indicates the last time the router was reachable and active, along with details such as its current allocation to a GSM port for use. The C logs button provides further insight into this activity. Similarly, the M2 last seen active timestamp shows when the device was last successfully registered on a network. Moving down, the wireless connected devices section displays the number of devices currently connected to the router via its Wi-Fi signals, combining both 2.4 and 5.8 GHz frequencies. Next, we have the software version field. This shows current software version. If a software update is available, a green update button will be displayed here, allowing for quick upgrades to the latest firmware. The admin link provides direct access to the device's Lucy interface for advanced configuration and management. Clicking this link opens the management console in your web browser. The M1 ICC ID and status shows the ICC ID of the SIM card in the M1 module, along with its activation status. In this case, the SIM is activated and configured for multi-MSI all TCP3, offering flexibility across multiple carrier profiles. Below that, we can view the latest speed test result, which includes the download and upload speeds, as well as the network and band used during the test. Finally, at the bottom, the best signal from last next scan section is accompanied by a map showing the device's geolocation and nearby tower connections. This provides a visual representation of where the device is operating and its connection to the nearest cellular towers. Now we're in the speed test history tab, where you can view detailed records of previous speed tests conducted on this device. There are two types of speed test available. First, we have the normal speed test. Then there's the rapid speed test, also referred to as IPERF. As the name suggests, the rapid speed test is faster and more efficient than the normal speed test, allowing for quicker assessments of network performance. Each test entry here displays useful information, such as download and upload speeds, the carrier, the primary and secondary LTE bands, the test result status, and the time the test was last updated. This data helps us track and analyze the network's performance over time. Next, we explore the NetScan history section. NetScan can be started by clicking on the Start NetScan button. It usually takes 3 to 4 minutes for a NetScan to finish. This feature records and displays the results of network scans performed by the device. These scans are crucial for understanding the signal availability in the device's vicinity when the M1 module is reachable, meaning the device itself is online and operational. By clicking on a specific scan result, a detailed breakdown appears, showcasing all detected networks in the area. Each scan result provides a summary including the number of successful results and the signal strength metrics, such as reference operator, radio access technology, band signal strength, and the corresponding operator name. These metrics are vital for diagnosing connectivity issues, such as weak signals or interference, and for deciding on band locking or carrier preferences to optimize performance. If needed, the network scan results can guide adjustments to the device settings, ensuring it connects to the strongest and most stable network available in its location. Let's move on to the Net Diagnosis tab. We can start Net Diagnosis by clicking on the Start Net Diagnosis. Afterwards, we need to click on RT Detailed or RT Fars depending on the nature of the preferences. When you have selected the option, press the Start button. The network diagnosis function is a powerful automated feature designed to evaluate and optimize network performance. The process begins with a network scan where the device surveys all available networks and bands in its vicinity. This initial scan identifies all accessible carriers and their respective bands. Once the scan is complete, the system systematically tests these networks and bands by running performance checks, such as speed tests to determine the best performing carrier and band for the device. The results of these tests are automatically recorded in the speed test history section, providing a clear comparison of network performance. For instance, the diagnostic function may determine which carrier AT&T, Verizon, or T-Mobile offers the best signal quality and fastest speeds for your device at its location. This data is invaluable for fine-tuning device settings such as band locking or carrier selection to ensure optimal performance and connectivity. The steps of the diagnosis, including scan initiation, SIM allocation, and IPERF results, are logged and timestamped for transparency, as seen in the Net Diagnosis Results section. This detailed breakdown allows for easy troubleshooting and verification of the diagnostic process. This feature not only simplifies the process of identifying the best network but also provides actionable insights to enhance device performance.